you know, I've got friends that are engineers, end up going to all different sorts of places and having to do various jobs. And one of these is supporting the firefighters, okay? So we're going to look at firefighters using hydrants to connect their hoses to the main water mains. I mean, what can you tell me when you look at that map? And this is somewhere in Florida, Windermere, downtown in Florida. What can you tell me? What you notice? Megan, what do you think?
They all kind of like blocks. It's all kind of like a grid.
A grid. It's a good word. So we've got grid and blocks. What else, Bradley?
There's no roundabout at some of the states.
Yeah, so there's no roundabout, which is what we tend to have a lot of. If a real city wants to do this, are they all going to be the same shape and size? No. So we tend to do something in maths called modelling, where we try something out and then try and fit it back into the real life situation. So this is your task in a way. You're going to imagine a city where all the streets are laid out in the grid that you've said and are all in blocks. Now, not always are they going to be in an exact measurement, but for our modelling exercise, we're going to say they're 100 metres squared. The fire department have hoses that are 100 metres long, so they don't need a hydrant on every street corner. So if I go back and I look at a section here, can you see that I've drawn that rectangle there? So I've picked just a section of it to have a little trial first of all. Yeah? And if I look at that, that's sort of a section that I've picked out. You need to think about where you might place the hydrants.
You just put on like there or something, and then that was quite there.
Have you covered everything?
Or one on each board.
Yeah.
That's not gonna work.
So have another look and see.
But that one covers them ones. That one covers them ones. That one covers these ones. And then that one covers them ones.
That hose can go to that house. That one can go to that one. There, and there. So.
But then how will you get a hose there, down there? Because that can only reach probably down there and down there. You won't be able to get a hose down there.
You have two firemen. Two there.
But it's not about the fireman, it's about the hydrants. So you got one there, but you can't get any. You haven't got any hoses to go around there. You got one that goes there, but not around there.
I'm just thinking about the front of the house.
Yeah, what happens if there's a fire at the back?
Oh, I didn't think of that.
Now, is anyone willing to come up to the board and show where they think the fire hydrants go? But what is the number that we think is the minimum? Oh, Jake, how many? 7. Is if we are a company trying to sell sort of what we're doing here in terms of placing the fire hydrants, we do not want it to cost lots of money. We want it to cost the minimum amount of money. So we don't want fire hydrants on every corner. So let's just check here. So you're quite happy. Those ones in the middle will cover. That one, oh, there's an overlap, someone's saying. So is that the most efficient way? Adam? Yep. Has Adam covered every block and he's done the centre bits? Has he done any doubles? No. So he has been very, very efficient. What I would like you to be able to do is investigate for different size grids. Why is that the most efficient and the minimum number of fire hydrants? How do you know?
Because it covers every house.
It covers every house.
It doesn't overlap.
It doesn't overlap. Is there any pattern that you've noticed so far?
Yeah, they're like it goes 2, 1,
Yeah.
2, 1, 2, 1. So if we could have one in the corners this time, yeah. And so they'd cover like that. And then if we could have one there, yeah.
and they would cover that and that bit. Yeah, so that would cover
there and there.
Yeah, that's right. And put one,
And then if you put one there, but that's basically the same though, isn't it?
yeah, but we've got. Oh yeah, but it's got more.
Alright, take that out. Put 2 down there, where we put those there and there.
Yeah, but you don't do next to each other or their overlap. You have to leave one space in between each one.
Oh, okay. So where'd you put the dot?
So you put the dot in the middle and you
There.
go that way and
There,
then down.
go
Yeah.
there,
And you keep doing that, but you would jump that space to go there.
Alright, no.
And you keep going like that.
Okay, I get it.
And then all that down the side, then you do a plus to for the centre ones, and then once again you leave a space, and you don't go the one down, so you move over. So it's basically the same as the size, but there's one more line.
Can you tell everyone what you've done and what you've noticed?
Well, like, on like the 1 by 1, I've started at a corner, and then it's worked. And then like 2 by 2, I've missed the corner. And then 3 by 3, I've started at the corner. And then like the 4 by 4, I've missed the corner.
Well, I found a pattern between the numbers of hydrants needed. Between the 1 times 1 squared, there's 2 hydrants, and then the 2 by 2 squared hydrants, there's 4, and then each time it sort of goes up, there's 2 number of spaces between 2 and 4 hydrants, and then between 4 and 8 there are 4 hydrants, and then 8 and 12 4 hydrants, and then it keeps on repeating and the pattern goes up. It's better not to go in the corners, because if you go in the corners then you only have 2 ways, and then if you go like not in the corner then you have 3.